Okay, so again, we've learned our Pythagorean identities. We learned the alternate forms of the Pythagorean identities, and now we're going to put one of those alternate forms to use. This problem is going to work very similar to the last example we just did. Okay, so we are told that secant is equal to 8, and that theta is in the fourth quadrant, and we need to find all 5 remaining trig functions. So there is only one form of the Pythagorean identity that we learned that involves the secant function. That form is this one right here. Tangent squared plus 1 equals secant squared. So if we know tangent squared plus 1 equals secant squared, then we can just substitute, solve for tangent, go from there. It's a little bit trickier here to get to reverse engineer sine and cosine, so let's follow that carefully. We know that secant is 8. So when I substitute here, that gives me tangent squared plus 1 equals 8 squared. And now I'm going to go ahead and solve for tangent. So tangent squared plus 1. Try to be careful that your squared looks like a squared. Sometimes I get a little sloppy with that. Tangent squared plus 1 equals 64. I'll subtract 1 from both sides and get tangent squared equals 63. And now I'm trying to get tangent by itself. So I'll cancel the square root, or I'll cancel by taking the square root. And that gives me the square root of 63 for my tangent function value. Not a very attractive number, but it's fine. All right, so now, square root of 63. But we do need to pay attention to whether that's positive or negative. Well, remember, this angle is in the fourth quadrant, and in the fourth quadrant, tangent is negative, so this is negative square root of 63. Getting tight in there. So we've got, let's see, we have one trig function. We just found the second one. And now we need to find the others that we're missing. Okay, this can be a little bit awkward here, but if we come back to the secant function, if I know that secant is 8, and I know that secant is the reciprocal of cosine, that would mean that cosine is the reciprocal of secant, and the reciprocal of 8 is 1/8, so I know cosine is 1/8. So I just found a second trig function, or excuse me, a third trig function. I've got 3 out of 6 now. Okay, and it can get a little bit weird. There's a few different ways that one might want to go about the next few steps. But now that I know cosine, I need to find cotangent, sine, and cosecant. So once I know sine or cosecant, then I can just flip that to find the other one. Finding cotangent, I already know that tangent is negative square root of 63, so as uncomfortable as this is, negative square root of 63, the reciprocal would be 1 over negative square root of 63. And if you did want to rationalize, actually, why don't we do something else? Before we rationalize, before we do that reciprocal, hopefully maybe you noticed that this radical can simplify. That would be the square root of 9 times the square root of 7, which gives us negative 3 square roots of 7. So a better representation of that value would be negative 3 square roots of 7. Now if I move on again, if I want to find the cotangent function, I'll take the reciprocal. That's 1 over negative 3 square roots of 7, which if you put that on a test, I'm probably going to give you credit for it, but I would like to see you rationalize it. When you do rationalize it, you get negative square root of 7 over 21. Not the greatest looking number, but it's fine. So there's our fourth trig function value. Now we're missing sine and cosecant. So we have a couple of options here, but I probably would lean to, well, if I were you, I would probably lean toward using the sine squared plus cosine squared formula. We learned this identity that tells us how to find sine if we know cosine. So since we know that cosine is 1/8, I can plug that in here, and I'd have sine squared plus 1/8 squared equals 1, and then I'm just solving that for sine again. So sine squared plus 1/8 squared is 1/64. That's equal to 1. 1 is 64/64. So when I subtract 1/64, I get sine squared equals 63/64. And then I would take the square root. And that's going to give me sine theta equals, we already saw that the square root of 63 simplifies to 3 square roots of 7. So this would be 3 square roots of 7 over the square root of 64 is 8. And then pay attention to quadrant. We're in the fourth quadrant where the sine function is negative. So we need to make sure it's negative. Okay, so we'll just make a note. This is because it's in quadrant 4 that it's negative. And we just found our fifth trig function value. We just need one more. And I'll sneak it into this space. Sorry to go backward. But we know that sine is the reciprocal of cosecant. The last value that we're missing is cosecant. Cosecant of theta then is the reciprocal of sine. That would be negative 8 over 3 square roots of 7. If I were to rationalize that, this is a little kooky here, but we would get negative 8 square roots of 7 over 21. And that is our sixth and final trig function value. So this is undeniably tricky and computationally intensive, and I know that you're not going to necessarily love it. There's lots of steps, lots of opportunities for mistakes. There's a good chance I made a mistake without realizing it in this problem. And if you find it, go ahead and let me know and I'll correct it. Basic idea here is to make sure we know that we can apply the Pythagorean identities in order to find missing trig function values. That's exactly what you'll be doing tonight on the homework. So you'll get lots of practice. Good luck with that.